Hello my friends and welcome back. Today we are continuing our series of lessons on Siemens Semantic Manager, and today's topic is the addressing in Siemens 7. And in this lesson we will learn how to addressing works in Siemens PLC, how the CPU access input, output, memory, timers, counters and data block. And as I said before, we must take several theoretical lessons, and after that we will continue in practical ways. So my friends, when you faced with the controllers and the model, how you assign the address of the model and how you assign to address to input and output of this model. Take this one, and here we have the 16 bits, 2 bytes model, and the address of this start from the, let's open in our Paint. Let's do it like this. Okay, like this. And here, my friends, our address start from the 0.0 to 0.7, and the second one is the second byte address is 1.0 to 1.7. and let's return to previous picture. And here, my friend, how we calculate the address of each models. We have a simple formula for addressing, but before let's talk about how addressing is related to the slot in the Siemens S7 rack. And first slot is always for our power supply. The second slot is always for our CPU. Third slot is it's not here, but it's always reserved for interface module IM, for communicate between your central rack and extended rack. And the slot from 4 to 11 used for DI, DO and analog input and analog output models. For digit input and output models, Siemens reserved the 4 bytes of addressing space per slot. And why is 4 byte? Because 1 byte is 8 bit, and the system reserve 4 bytes for each models, and the typical digital model can have up to 33 channels. And how we calculate the address, let's take a look at the formula now. And our formulas is let's write it here. I think it will be good. Let's resize this one. And so base address for our digital input or digital output is the base address is equal to slot number minus 4 multiplied by 4 plus rack number multiply by the 32. Besides this one, my friends, let's take a simple example. For example, if your model is installed in rack number 4, rack 0 is a core rack, the first rack of our system, and we use the slot number 4. What we will do? Firstly, let's open our notepad, and here let's calculate. And our formulas is there. Is here. Let's do it like this, and let's resize this one also. So we start from the slot number is the 4 minus 4, okay, multiply by 4. I think now we will not continue to calculate because the base address is equal to 0. So our first base address of the modules which installed in slot number 4 is the start from 0.02 if we use the 4 bytes modules, and finished with the 3.7. And let's take another example. For example, if we have suppose we have the 16 digital output and 16 digital input models, and we install it in our rack number 0. Let's calculate by our formulas, and base address is the, and we install in slot number 5 our model, this model. 5 minus 4 multiply by 4, and then our rack number is 0, and we will not calculate this part, and this means that our base address starts from 4. It's mean for digital input we use the input 4.0 to 4.7. It's for the first 8 digital input, and for the output we use Q4.0 to 4.7. And my friends, so we use the, since we use the 16 channel models, it's continued by the 5.0 to 5.7, and the same for the Q, it's 5.0 and 5.7. And my friends, all these formulas applicable for the S7 300 and also for S7 400, but for the S7 400 we have some exception, and it has an important concept called the geographical addressing. In S7 400 PLC, each slot in the rack is automatically assigned a certain address space by default. The default address is determined by the rack number and the slot number. And let's take some example. And if we want to assign the address for central rack, we use the formula like this. Let's write it down. For the base address to digital signals, we use the formula is the slot number minus 1 and multiply by 4. For analog models in central rack, we use the base address formulas like the slot number minus 1 and multiply by the 64 and plus 512. And my friends, one more notice why the address calculation different for the analog models. Digital models store only on-off signals, so they require very little memory. Therefore, Siemens reserved the 4 bytes per slot. Analog models store numeric values such as temperature, pressure or flow rate, and may also include the diagnostic information. And therefore, Siemens reserved a much larger address space of 64 bytes per slot. And plus the 512 separate analog address from the digital addresses, making the memory organization easier and more structured. And that's all for the addressing. Not all, sorry. One more thing. One thing about the expansion racks for digital models is the base address, or you can say the start address. Address is calculated by the formulas like the rack number multiplied by 18 plus slot number minus 1, it's for digital, and multiply by 4. And for the analog addresses is the same like this. Let's do it like this, copy and paste it here, but we multiply it by 64 and plus 512. And why we multiply for 18? Because the expansion rack can contain up to 80 slots. So my friends, that's all for today, and in the next lesson we will talk a little bit internal addressing of PLC and how can it read the data from physical output and send data to physical output and analog output, and how it reads data from analog input and digital input. And I wish you good health and good luck. Subscribe to our channel and hit the like button if you enjoy the video and find it useful for you. Thank you very much. See you in the next lesson.